Hello everyone, my name is Drew Sukup. On behalf of VMUG, I'd like to welcome you to today's MinIO webcast, introducing MinIO Object Storage on vSphere with Tanzu using vSAN Data Persistence Platform. Presented by Ugur Tigli, CTO at MinIO, and Gopala Suryanarayana, Product Line Manager at VMware. Thank you for participating in today's webcast and for your continued support in the global VMUG program. Before we begin, I have 3 quick housekeeping items to go over. First, today's webcast will be recorded and available for you on demand. You will receive an email with the on-demand link, so keep an eye out for that. Second, a Q&A session will follow today's presentation. All questions will need to be entered into the question window near the bottom of your GoToWebinar screen. Third, there will be a short online evaluation that pops up as you exit the webcast. Please take a minute and let us know what you thought of today's session and what you might like to see going forward. All attendees from today's webcast who opted in their information at registration will be entered into a raffle to win a $100 Amazon gift card. The winner will be contacted directly by MinIO, so good luck. And I mean, good luck indeed. That is some nice Christmas present cash. All right, let's get started. Gopala, I'll turn it over to you now.
All right, thanks, Drew. All right, welcome everyone. Thank you for attending this talk. So we will be going through the MinIO integration on vSAN data persistence platform. Just the standard disclaimer here, we may be talking about features that are coming up in a future release. There is no guarantee that any of them will make it or any timeline around those feature availability from VMware or MinIO. So with that out of the way, let us talk about applications a little bit, right? So we are talking about the MinIO integration on data persistence platform. But before we talk about why, how we did it, I want to touch a little bit upon why we are doing it. So primarily, the reason we have been thinking about these kinds of offerings is that the applications in the enterprise, in the customer deployments are changing. What used to be monolithic applications that were designed using the traditional architectures are now giving way to these microservice-based applications, primarily because the customer needs have changed from these enterprises. These applications are now highly scalable. They need to span geographies. Most of the times, the IP of a company is its software, so it needs to be iterating on this IP pretty fast, right? And this is the reason companies are moving towards a microservice-based architecture, which essentially means that applications are now a set of many microservices, right? Each of those microservices is independently developed, independently iterated, and lifecycle managed, right? So this gives a lot of agility for enterprises in that they can get to the market, their IP much faster, they can be competitive, and they can meet their users' demand much better with the microservice-based architecture, right? And it turns out that containers and Kubernetes lend themselves extremely well to such microservice-based architectures, right? So the reason for that is once you blow up an application into many multiple microservices, it now presents a management challenge, right? So the management challenge is solved by Kubernetes, right? So Kubernetes has become the de facto management platform for containers, and that's the reason you see that microservice and Kubernetes have become almost the established norm in these microservice-based architectures. And it turns out that when we started off, Kubernetes was a platform for stateless containerized applications, right? And state was managed outside of Kubernetes. But what we are now seeing is Kubernetes is maturing, and very quickly it has become the platform for even managing stateful containerized applications. But of late, we now see that some of these highly distributed stateful applications, like the MinIO Object Store, they also are being managed by Kubernetes. primarily because Kubernetes has this has something called an operator framework, which makes it extremely simple for people to manage, deploy, and operate these kinds of stateful distributed applications, right? So that's the reason we see that Kubernetes has become the de facto norm for even managing some of these highly distributed stateful applications. So that was an overview of how the applications are changing, how Kubernetes is becoming a norm for stateful applications. Another view of the enterprise is what these modern applications need from a storage perspective, right? From a persistence perspective, what do these applications need? So if you look at that particular picture, what used to be a simple application in the past that depended on a single instance of a database is now quickly becoming an application that depends on not just one database, right, but a variety of stateful services. Right. So what I mean by that is now this modern application has a need for a NoSQL database, right? So it has a need for in-memory caches. It has a need for object stores. It has a need for all the different stateful services that actually make a modern application come alive, a geographically distributed modern application come alive. And that's the reason you see that now you have all of these different stateful services show up. And among them, almost exclusively object stores stand out, right? So that is the reason we in VMware have built this platform primarily around the object store use case, because object stores have multiple different needs from the application side. One of the primary need for the object store is as the default storage platform for modern Kubernetes applications. In the past, when developers used to request for a NAS or a SAN-based storage using a corporate ticket, this is no longer the case now. Developers use self-service, Kubernetes consumption, cloud consumption models, and request for an object store endpoint, right? So that is how storage is consumed in the modern cloud model. So that's the reason object stores have become the mainstay. And not just that, given the flexibility of these object stores, they lend themselves extremely well to different types of applications, all the way from high performance analytics, AI ML use cases. You will see that we are going to be discussing those in a minute. And all the way from those kinds of performance sensitive applications to the cheap and deep dense storage kind of use cases. Object stores lend themselves extremely well to both of these types of different use cases. And that's the reason object stores are becoming the mainstay. And along with that, you also see some of these other applications like Mongo, Cassandra, Kafka, etc. So what we have done in the data persistence platform, as you will see, is we have built a framework to integrate all of these different stateful services using Kubernetes, so that we expose them using the consumption models that customers and developers have been looking for. Right. So this is a number slide here, just to show that it's not just the nature of these applications that is changing, but along the way we are also seeing an explosion in the number of such applications. Number of these modern applications has been growing, and by some estimates, we are going to see 500 million of these new applications come on the enterprise data centers in the next few years, right? And that's a lot of applications. 500 million is a lot of applications. And the other trend we also see is application teams are spending more and more dollars on their IT spend. This goes to show that developers have more control and more say in what kinds of infrastructure gets deployed in their data centers. So given these trends, we want to make sure at VMware that we build a platform that our customers will choose, right? That is going to help them be very agile, get their applications to the market as soon as possible, be competitive in the industry, and provide that platform for developers really that will work for them, right? So with that, VMware has done a lot of organic as well as inorganic kind of efforts to make this possible. And data persistence platform is one of our organic efforts to bring on these kinds of stateful services on VMware Cloud Foundation. So this is again an analyst estimate here that goes to show that Kubernetes is becoming a standard when it comes to private public hybrid clouds, and most of the architecture that customers and developers use is based on Kubernetes, right? So you see these numbers, such as a lot of these respondents that we talk to are using Kubernetes in their enterprises. And the number of container instances is also extremely rapidly growing. So both these trends are clear indications that Kubernetes is becoming the standards, containers are becoming the standards, and we need to support these kinds of architectures and workloads on the enterprise data center. So now that we have motivated the need for bringing on services like object stores, let's talk about how VMware is actually making that possible, right? How is this becoming a reality at VMware? So one of our first announcements, a major announcement in this area, has been Tanzu, right? And the way that we take Tanzu to the market is by using the VMware Cloud Foundation vehicle. VMware Cloud Foundation, as a quick refresher, is the full stack that is required to make a modern cloud run in the enterprise. It brings together some of the flagship components from VMware, such as vSAN, which is the industry leader in hyperconverged storage, NSX, which is again the flagship networking offering from VMware, and vSphere, which is basically the bedrock of virtualization and the modern data center, right? So VCF, VMware Cloud Foundation, brings together all of these marquee flagship components and puts them together in a very clean stack. And then not just getting these components together, network, compute, and storage, but it also adds that management layer in terms of vRealize a suite of products, right? So which essentially enables customers to put together that full cloud stack and also take care of the day zero and day two operations for the stack. With the compelling SDDC manager, customers are able to put together the stack and make sure that all of their day two lifecycle management operations for all of these different components in the stack is taken care of. They get that vRealize management on top of it, which becomes extremely compelling to have this private as well as hybrid cloud stack deployed in their modern enterprise. So that is VMware Cloud Foundation. So what we do with VCF with Tanzu layer is we now turn this private cloud, hybrid cloud stack into a modern Kubernetes platform. So Tanzu, the promise of Tanzu is about bringing Kubernetes natively to the VMware hypervisor, right? So with that, we enable a few of the use cases. One of the primary use cases that we are going after with VMware Cloud Foundation with Tanzu is the ability to offer conformant Kubernetes clusters to developers that want to develop vanilla compliant Kubernetes applications on VMware vSphere. What this means is now you get on-demand Kubernetes clusters that are handed off to these developers using Kubernetes APIs without them having to open tickets. They can just get these Kubernetes clusters deployed using self-service. Now, with this, they can just get any of their applications that are running on a generic Kubernetes cluster. It could be on the cloud, it could be on bare metal. They can get any of those applications deployed on this platform that we're calling TKG service, which is Tanzu Kubernetes Grid service, which gives them the vanilla Kubernetes clusters without them having to modify their applications one bit, right? So this is quite an important aspect that I want to emphasize. This gives developers a very compelling platform for them to develop their applications. So that is TKG service. And then with pod service, we are able to run some of these applications natively on the hypervisor, which essentially extends all of the availability, security, and efficiency to these modern Kubernetes applications. Now, with VCF with Tanzu as a platform, we are introducing vSAN data persistence platform, which builds on top of VCF with Tanzu. and essentially enables customers to run some of these modern services on the VCF with Tanzu platform, right? And in this talk, we will be talking about the MinIO service, which is going to be available on VCF with Tanzu. And essentially, with this integration, what we are enabling customers to do is we are giving them a one-click deployment, right? One-click enablement of MinIO on this platform. Consuming MinIO using a self-service, the cloud consumption models, as well as simplified operations for vSphere administrators, right? What we mean by that is operators will be able to manage MinIO like they have managed file and block abstractions over vSphere and vSAN. That same level of integration with vSphere operations like maintenance mode, like lifecycle management, the health monitoring, the capacity monitoring, all of which were available to the vSAN users are now available to MinIO as well on this platform, right? And one important aspect of this integration is also the capability to now turn off the availability on the vSAN layer, which is basically enabling only the availability to be enabled on MinIO using the MinIO erasure coding and turning it off on the vSAN layer. This is important because when customers are choosing MinIO on the data persistence platform, they want to be able to use the MinIO erasure coding and turn it off on vSAN, because this will give them better TCO, right? So this is going to save the cost of replication for data. And that is what is one of the key pieces of our offering here. We make that possible with the reduced TCO operations for MinIO. And with this, we are also offering 2 deployment options for MinIO on top of data persistence platform, rather actually 3. Let me talk about all of those things. The first option is you can deploy using the regular vSAN mode, wherein you turn on the vSAN availability as well as MinIO availability. So in this case, you have 4-way replication for data, right? So if you choose 2-way on MinIO and 2-way on vSAN, you have 4-way replication. So this will give you that extra peace of mind of both replicating data on MinIO and vSAN. But what we believe is the other 2 options where you turn off the replication on vSAN, that is going to be more compelling for customers because that will reduce the TCO for operating MinIO on the data persistence platform. So the mode called vSAN SNA is deploying MinIO on vSAN, but by turning off the availability on vSAN, right? So that's the reason you see that this mode is only using the MinIO availability, the erasure coding. And then what vSAN does is it lets those objects that are coming in to vSAN be deployed on the existing vSAN cluster, but by turning off the replication here, the availability. And the use case for this is primarily when customers have an existing vSAN cluster that they are using to deploy their file and block-based workloads, and they also want to consolidate their object store workloads on the same cluster, right? But by turning off the availability on vSAN. So this gives customers a quick way to deploy object stores, right? Without a lot of new additional investment, they can get object stores deployed on their existing vSAN clusters. The other way is to use something called vSAN Direct configuration. The idea behind vSAN Direct is that you want to get the bare metal efficiencies with respect to TCO and performance, but you are also looking for the integrated management with vSphere, right? The HCI management, the Kubernetes consumption model, the self-service. You're looking for all that, which are not available on the bare metal appliances, but vSAN Direct provides you the best of both of these worlds, right? So you have that same bare metal efficiencies because you will see in the next slide, I'll be talking about vSAN Direct. You get to deploy it on the direct attached storage devices to get you those better efficiencies, but you still have the management aspect coming in from vSAN and Kubernetes. So that's the kind of use case for customers on vSAN Direct. Right. So like I mentioned, vSAN Direct is another offering along with data persistence platform that we announced, and we will have MinIO be using it in a bit. Right. So here what we do is we directly go to the underlying hardware devices like SSDs and like cheap and deep hard disks to give you that better cost optimization and better efficiencies with respect to TCO. And the data availability is completely delegated to MinIO, right? So you use the MinIO erasure coding schemes and you turn on the data availability, but you get those better storage efficiency, higher density of storage. All of the properties that you get with bare metal, you get it with vSAN Direct, but with the turbocharged HCI management as well as efficiency. So can we get the first poll question out? Yeah, so this is a poll question that we are asking to see what your plans are to upgrade to this particular platform to get the support for MinIO Object Store. So please do answer this poll. This will help us get a sense of what your plans are. Okay, all right. So I will now hand it off to Ugur, who will talk about some of the use cases as well as talk about some of the MinIO properties. Ugur, take it over.
Sounds good. Thanks, Gopala. And I'm going to be asking Gopala to help me with the slides as well. So as we go through the slides, I'm going to be talking about three things in this section. I'm going to be talking about why object storage became the new class of storage solution for all the things that Gopala mentioned. The customers' deployments are changing and why they are choosing that. Secondly, I'm going to talk about why MinIO in this landscape of changing world of Kubernetes as well as cloud native applications. And then I'm going to try to give you guys an explanation of the use cases, why MinIO has been very popular in terms of which use cases our customers has been using us. And then when they move into the modern world of application development, how they're going to carry MinIO together with their use cases and applications. First of all, the RESTful API nature of object storage and S3 became very important because cloud native applications, as Gopala also mentioned, when you divide a monolithic application into pieces, you need more of different services, and you need that glue that connects them together. And RESTful APIs for that are S3 became that glue, and S3 became the de facto standard, just like Kubernetes became the de facto standard for modern cloud native applications. S3 became the de facto standards for the protocol. I used to use block and file in old worlds, and POSIX has been for the file system, or fiber channel connectivity has been the technologies for applications and infrastructure connecting to each other. But in the new world, you are not bonded with the data center boundaries. Hence, the world became where the internet can reach, and with public clouds and private clouds and hybrid clouds becoming together, S3 over HTTP and regular higher level protocol became the de facto standard and made life so much easier for all application developers, as well as the infrastructure people who are supporting it. In terms of scale, we grew from terabytes into exabytes in most of the hyperscaler deployments that are using, whether it's public cloud or private cloud, the same concept of large amounts of storage became the use case, whether from an ingest perspective, data collection perspective, data is clearly growing, and it's the insights the business are getting from that data became quite important, and the scale is in a different level nowadays. In terms of the efficiency and resiliency when it comes to the object storage, the erasure coding, the replication model, as Gopala also mentioned a few times, that the total cost of ownership became very important when you go into a cloud native world and you're trying to not to overlay some of these technologies, and efficiency and resiliency became important. And object storage provides erasure coding, bit-rot protection, some of the locking functionality, as well as replication as well if it's required. But these technologies made object storage a popular choice from a TCO perspective and ease of support and ease of deployment perspective. When we go to Kubernetes, when we go into the next slide, this talks about how MinIO specifically and object storage such as MinIO can be easily deployed anywhere, whether it's in public cloud, private cloud, hybrid cloud, doesn't matter that framework, because Kubernetes provides a great abstraction and you can fully containerize your software, especially MinIO, which is written in Golang. We have a very lightweight binary, about 40 megabytes, 45 to 50 megabytes in the last releases. And you can easily, using the Kubernetes frameworks like Operator that we talked about, you can easily spin off stateful services within an operator model, and having operator CRDs, custom resource definitions, and management console, you can have all of the pieces that you would need to create your own self-services, bucket as a service type of a deployment. And we started with this journey with some of our customers using this concept of bucket as a service in a Kubernetes world and deploying it per tenant, per development group, and going to the granularity. And it bridges the two concepts of IT administrator managing the resources, as well as developers and development groups having the independence and flexibility that they require. So it's kind of bridging the best of both worlds, and having this lightweight persistent storage service that can be deployed within Kubernetes is a great combination of best of both worlds, in my opinion. When we go into the next slide, we mentioned a few analyst kind of research for Kubernetes, and the same dynamic applies to the industry. We can see that clearly S3 object storage, S3-based object storage is becoming the de facto standard for most enterprises, and the numbers are tripling, and that shows popularity around there. And we see that software-defined storage, software-based persistent storage solutions and object storage solutions are becoming the de facto standards. And infrastructure and operation needs multiples of clouds. The concept of having public and private and hybrid, it's all kind of merging, because once you have the Kubernetes as your abstraction, it doesn't really matter where you're running your services. You can run a MinIO service within Kubernetes, and that Kubernetes instance or cluster could be sitting on a public cloud, could be sitting on-prem. It doesn't really matter. It's just the ease of management and ease of scale what development teams care about and require, and that dynamic is pushing them into, from an IT administration perspective, into a framework as such, and they can just choose which environment they will be running their application. When we go into the next slide, I want to just talk about why MinIO specifically from all of those software-defined object storage solutions there, and why VMware started working with us early on, and now we are talking to you about the VMware Cloud Foundation with Tanzu as the founding block, and then we are talking about how we can take vSAN direct configuration and expand it to a larger scale deployment when you go into Kubernetes and when the data is still growing and you really need to have huge amount of storage. When we get into the use cases, I will talk a little bit about that. So two things that comes to mind when you talk about MinIO in general and specifically. MinIO can be deployed on bare metals, can be deployed on VMs, and can be deployed on containers, no problem. The concept is the same. And Gopala mentioned a few of them, that we do the erasure coding and bit-rot protection, and you don't really need the appliance or the hardware layer or the layers below MinIO to do similar things. If you let MinIO to do the replication erasure coding closer to the application, it gives you more flexibility, better manageability, and better TCO. The main two things that people always talk about MinIO is performance and simplicity to deploy and management, which kind of translate into operational savings and operational ease. Performance, we've done a few things that are really unique to MinIO. We kind of use a modern language from a Golang perspective that gives us a few advantages when it comes to streaming data and things like that. And then we also, whatever hardware that's provided to MinIO, we use this the hardware architecture in a way that others are not taking advantage of. If we have later generations of the Intel chipsets or AMD chipsets or ARM, whatever the architecture that we are giving to, we make sure that we use those architecture to the maximum. Essentially, we use some of the registers in those architectures to do the erasure coding calculation rather than using the CPU. That gives us a huge advantage from a performance. And when we do our benchmarks, that clearly show itself. And we publish these benchmarks and on our website, and some of our application use cases really go after this high performance. Software defined, being the software only solution, is also critical, and that gives the simplicity of management and deployment. As I talk about, we can be at the edge and a small ARM chipset, or we can be in a data center when you have bare metal and you try to stitch together a huge data pipeline or an AI analytics pipeline that just requires tremendous amount of storage, and they don't really use any abstraction, but just pulling a lot of data together, raw data, and then different phases analyzing that. So those are critical pieces. The manageability and total cost of ownership is kind of the second half of that. Simplicity brings in better TCO and easier manageability. And the last part that I want to talk about, two pieces actually, security and compliance. We've done a lot of work in terms of the encryption, whether it's client provided encryption frameworks that is also standard from an AWS S3 perspective, or when we're doing compliance where we have warm and where we have object locking type of compliance. That opened up many use cases, from backup use cases to archival use cases that requires compliant checks and balances. MinIO became a popular choice for that. And combination of all of these things that I talked about provides the large amount of application catalog that we bring to the table when you integrate into Kubernetes or when you integrate into VMware Cloud Foundation with Tanzu. MinIO brings tremendous amount of portfolio of these applications that are already using MinIO, and they're just changing their way of deployment, way of using their application. With the next slide, I'm going to talk a little bit about Kubernetes, how MinIO is truly built for Kubernetes and natively integrates into Kubernetes. When we did the integration as well, MinIO has been written just to be the de facto standard for S3 compatibility, but it's also written natively for applications. We have SDKs, we have RESTful APIs that are not classical and legacy, and applications choose us for that purpose when they start early on their development. Once they go into different phases of their application development, ease of use of MinIO makes us at the center, and data is quite important for any application. And when they go into production, MinIO becomes the persistent layer for them, just like NoSQL databases we talk about, or Kafka being the message queue. We can become the very important and core part of their application value. And the S3 compatibility comes into the picture as a standard. It's a de facto standard. In the last maybe 7 years, 8 years ago, people were trying to understand or get their heads around the S3 compatibility and using S3 APIs. But essentially nowadays, S3 became what NFS or CIFS were 20 years ago for a file system. S3 is the de facto standard for that, and everybody is kind of accepting that as a way to use object storage, blob storage in the new world of containerized and Kubernetes managed world of new applications. And when you look at MinIO instances or MinIO use cases, we see that 61% of all of our instances are containerized, and that's a huge number. And that 60-40 percentage is a great number to talk about, and our users base reflects how containerization is important for them. And out of those, 48% of them are managed via Kubernetes. And all that work that VMware has been doing with Kubernetes show the numbers are pretty similar. We saw a number that is in the 50% range, and we are seeing here in our own numbers that Kubernetes is 48% of those that are deployed. So it's clear that people are moving towards in a containerized Kubernetes managed world, and they want all these services, data persistence services from whoever their choice of Kubernetes deployment that they are using. In the next slides, I will just mention briefly which is very much what Gopala already covered and explained to you guys, how we are part of we are a layer on top of the VMware Cloud Foundation with Tanzu, and we can be deployed in different ways with vSAN direct configuration, or we can be just at the core of the whole VMware Cloud Foundation building block, and we can use the supervisor cluster to spin off different namespaces. The key point that you need to get from this picture is VMware brings MinIO into IT, and we are the bridge that can provide both a classical way of managing resources in the data center, and this becomes very important when you talk about AI, ML, big data type of use cases where your data is huge. Your convergence type of storage approach will not be enough. You will need to go above those boundaries, and when you go above those boundaries, vSAN direct configuration we talked about becomes very important, because you want to be managing all those resources and bring them into the same way that you manage vSAN. So that's critical, and MinIO plays a very critical role in this journey, in my opinion. So with that said, MinIO is a critical piece in the VMware vSAN direct configuration, especially with a few use cases, which I'm going to get into in a few slides. So use cases, this is the third area that I wanted to focus on, and then link it to vSAN direct configuration, which is the last couple of slides that Gopala also mentioned. This is critical because you can do many things in a small scale in terms of, MinIO being very small, and it can be containerized and deployed within Kubernetes. But when you go into an enterprise deployment, and then the size of the data is growing and you need more insights from that data, the dynamics, the scale becomes very important, and the low TCO becomes really important. All those combination factors needs to be handled in a different way, and MinIO and VMware vSAN direct configuration provides you all of the benefits in that sense. So backup and archival. So backup is a critical area for any. Object storage attracts backup for many reasons. It's ease of integration, in terms of the low TCO aspect, in terms of trying to have object storage scale being much larger, and the boundaries are not being limited compared to file and block type of approach, attracts a lot of legacy and traditional backup applications to object storage. But when you talk about backup, you have to also think about like Velora and Kasten and Robin, these names here. If you just Google any of these names with S3 and MinIO, you'll find that they already have native integration to MinIO. And sometimes some of these applications that I'm going to mention, they don't even talk about MinIO versus AWS. They don't even have the differentiation between public private cloud. They just say S3, and S3 is that important in their integration, and you can use MinIO regardless in any environment. So we've done also a few other things with, for example, with Veeam, our integration. The object locking features that we have is critical for the Veeam integration. Veeam use versioning and locking to a tremendous degree, and us having all of this full enterprise feature set and versioning locking made Veeam customers easily switch over to MinIO and start using MinIO for their backup solution. And in terms of archival, the compliance part became quite important. We have a bunch of large financial services customers that are writing their own application, and they write their own application using compliance object locking functionality that we have. That we also worked with a third party to get approvals and to get certification for our object locking, and that is compliance. And we also have legal hold features for when it's required. So having all of that feature set made some of our customers use us natively using our compliance features for their archival solutions, whether for electronic archival for trading, electronic or recording of the voice recordings that they have in their companies. There are various applications that are using us, MinIO, for compliance as well as versioning capabilities within the archival use case. So second use case, which is the critical one that I mentioned, a few kind of hinted out, when you go into large scale data, then the scale of deployment and what we talked about vSAN direct configuration, when you need to take the vSAN manageability and expand it into managing multiple JBots, whether it's HDD, SSD, whatever the hardware platform is, but let the instead of running it within a hyper-converged environment, you can go and grow it to larger environments using very low-cost hardware solution. You don't really need to go into appliance model, which is the legacy platform that people are used to, but use vSAN management framework and manage a lot more raw data. And using MinIO puts them all together with performance and ease of manageability using vSAN framework. So TensorFlow, Spark, and Presto, some of the important one. TensorFlow is one of the most popular frameworks, as everybody is aware of, in terms of whether it's ML, AI, when you're starting with a small training of a model, or when you're going into complex models where you use the APIs for ease of use, or H2O, similar fashion. People start small, but when they need more data and their number of images or the number of text goes into petabytes, they just need a bigger solution. They need a bigger boat. So this is the critical piece for AI ML application, why MinIO is being chosen. In the case of Apache Spark, this is a similar approach. Apache Spark does most of its calculation in memory, and when you really increase the amount of data, you really need more to go into memory. You can't really fit everything into memory, so you need MinIO to be there for holding all of the rest of the data and then going back and forth into memory very fast and easily, so that you can do more calculations. In a similar fashion, Presto is being used in the industry as well. So I'm going to quickly go into two use cases that are common. In the next slide, we talk about mobile and cloud native applications. So a good example of this is like Box-like solutions, where they were using public cloud as their backend, or Dropbox is using the same model in the early days. But then when they scale out, there's a huge amount of repatriation of Amazon S3 going back to on-prem. So these use cases, when it comes to building blocks, they really come to MinIO, and they use MinIO as their very dense hardware platform using MinIO software on top of it become a really easy solution for them when they repatriate their data from public cloud. The S3 protocol stays the same, their application doesn't require a huge change, and they get the best performance from whatever hardware they throw into the mix. And that made MinIO a very popular choice across these cloud native applications. And we have different customers using different repatriation of S3 coming back to on-prem and then using it in a dedicated way with the hardware that they have. In the next slides, next two slides, I'm going to cover two types of use cases. One important one, and this one is analytics use cases. In some of these names, MinIO can be the destination or the target, the backend or the front end, if you will. In Splunk case, Splunk has something called Smart Store, which is an abstraction layer for their S3 to push some of their indexing data to S3. And that allows them to basically disaggregate storage and compute. And that gives them a huge advantage in terms of separation and making more modular and ready, their application ready for a cloud native perspective. So we integrate seamlessly there. And also we have a replication feature, an active-active replication feature. If you have two deployments in two different data centers, we have a software called Sidekick that makes Splunk indexers be aware of the MinIO S3 buckets, regardless of which data center they're in. And if you have a site failure, you can easily switch over to the second one. We have integration with others too, but I'm just going to jump into some of the other use cases in the next slides and briefly mention that. This is a critical, and I'm going to finish with this. This is a very critical area where you're starting small, whether it's in your own Kubernetes environment or in a small, or from a MinIO perspective. Most of our early adopters of MinIO, they start with this use case. Artifact stores, whether it's Armory, JFrog, or you have certain framework that you're familiar with, and you need to really create a bunch of buckets where you have to save all of these artifacts, essentially, whether it's the registries for containers or artifacts that you have. You create, and all of these names and logos you see here, they have native S3 integration. And it is such an easy use case to start with. And I see many customers start with this use case, and then they jump into larger different use cases when it comes to capacity, as well as the complexity from an object storage and MinIO perspective. So I just wanted to give you guys a flavor of all these use cases and what's possible out there. And with that, we're going to go back to a poll, and then Gopala will take it from there to show you guys a short demo of how we integrate into VMware platform and how we can be really easily managed from the existing tools that you're all familiar with.
All right. Thank you for your responses. Thanks, sir. So what I'll do in the remaining 10 minutes or so is I'm going to show you a quick demo of the MinIO integration on the vSAN data persistence platform. So basically what you will see here in the demo is we have a vCenter that is managing a bunch of hosts. And we have the MinIO operator that is enabled on a particular vCenter cluster. We also, as part of this integration, we are bringing in a native vCenter UI plugin for MinIO so that you can manage MinIO right within vCenter without having to leave the vCenter. You are able to manage MinIO deployment right within vCenter. So that is the backdrop for this demo here. So let's roll through the demo. So what we are going to initially do is, this is the vCenter, like I mentioned, and here you see the different hosts that the vCenter is managing. The namespaces here are primarily the namespace for vSphere with Tanzu, right? And that will give you a good way to get your applications deployed in these namespaces and also create a MinIO object store tenant for this namespace. Let me go back, I'm sorry. Yeah, so we'll first create a tenant here. So that's the workflow that you're seeing there. Like I mentioned, you can create that right within the vCenter, and then you create a namespace on which you want to create that particular tenant, right? So under this workload cluster, you create a namespace for, let's say, vMug, wherein you want to go and create a tenant, give it a name, a description for that particular namespace, and then have that namespace created. Now, within this namespace, you can give access to the different policies that you want a MinIO tenant to use, right? So in this case, what we are doing is we are giving it access to the vSAN direct policy to this namespace so that MinIO can be deployed using the vSAN direct policy that we talked about a little earlier. Now we can also use a vSAN SNA policy if you want to deploy MinIO on vSAN, but in this case, we will be talking about how we use the vSAN direct. So then you configure a tenant in MinIO. So you choose the namespace on which you want it created. You choose a storage class, which is the vSAN direct. And then you can also choose the MinIO properties, right? Like encryption, like any other MinIO specific property could be chosen here when you're creating a tenant. And then you come to specify what's the size of this particular tenant that you want, right? So you create a tenant. Now we're using 4 nodes, and you're expecting that you have a raw capacity of 50 gigabytes. You provide the memory per instance, and you also choose an erasure code for MinIO, right? So in this case, we are choosing an erasure code 8, which is basically dual replication. So that's the reason you see that the raw capacity is 50 gigabytes and then usable is 25 gigabytes. Right, and this actually gives you a good overview of the configuration that you've chosen for MinIO. Before you actually start this, you copy the credentials which is needed to actually go and access a MinIO object store, and that's about it, right? So the moment you choose to go ahead with this tenant creation, in the background, what the system is doing for you is it's creating the various MinIO pods. It's creating the persistent volumes on the vSAN direct configuration. It's attaching those pods to the persistent volumes, and it's pretty much waiting for that MinIO tenant to come up. We integrate this with the vSAN health, right? So all of the vSAN health integration has been extended to MinIO as well. And then once the MinIO tenant comes back up online, the vSAN health is showing you that the MinIO instance is online, right? So that's as easy as it is to create a MinIO tenant on top of data persistence platform. And after you have created it, we will go and see how you can monitor that particular tenant here, right? So what you're seeing here is we are able to show the capacity monitoring screen for MinIO. We also show the actual disk placement of the MinIO tenant on vSAN. Right, in this case, it is vSAN direct. So what you see here is how a particular MinIO persistent volume has been placed on the underlying vSAN cluster, right? So the node on which it has been placed, the disk group and the disk, all of that information is available as part of this integration. And then what you saw there was a tenant is made up of different pods. So you see the list of pods as well. And you see the health of all of those pods that are making up your MinIO tenant, right? And let's say now we have a need to put one of the hosts that is running a MinIO tenant into maintenance mode. You will see how seamless it is to actually do these vSphere operations like maintenance mode, even when the data for MinIO is not replicated on vSAN, right? So the beauty of this integration is even though MinIO handles all of the data availability, the data persistence platform talks to MinIO and makes sure that the data moves out of a node when you're putting a node into maintenance mode. to basically ensure that our customers have that operation seamlessly taken care for them, right? So in this case, we will choose a maintenance mode operation in the evacuate all data mode, which is full data migration, which is essentially telling MinIO to move all the data out of a particular node and then make sure that the pods and persistent volumes are moved to the other nodes within the cluster. So once you give an OK to the maintenance mode operation, what we did was we asked the data persistence platform talks to the MinIO operator and has it move the data out, right? And when the data was moving out, you saw that the MinIO pod for a moment became unavailable. But once the maintenance mode operation completed, we did see that the pod came back online, and MinIO service continues to be available after the maintenance mode operation goes through. Right. So again, to recap, you saw how easy it was to enable and deploy MinIO, to choose the storage class for this MinIO operator, and also you saw how to monitor health capacity for this MinIO instances. And lastly, we showed you how the operation is as seamless as a few clicks for maintenance and lifecycle when MinIO is integrated on the data persistence platform. So this was the final demo, and next I think we have a few minutes to take questions. And Jonathan, if you can give us any questions, we can answer them online.
Certainly. So I think one of the questions that came in: can you use vSAN stretched cluster combined with MinIO?
Right. So in the first iteration, we will not be able to use a stretch cluster, but this is something that we have been actively thinking about.
Got it. Can you use MinIO for VMF S6 data stores, or only with Kubernetes?
Right. So the way vSAN direct configuration is actually done, is architected, is by using VMFS. What that means is under the covers, it is VMFS that we are using on the local data stores, right? And then vSAN direct builds on these local data stores, builds the management for Kubernetes as well as vSAN HCI. So that's the VMFS connection to the vSAN direct piece here.
Got it. So is vSAN direct the recommended configuration of all three, or is it use case dependent?
That's a very good question, right? And the way that we have been looking at it is it's purely a use case dependent choice. Like I mentioned, there are two primary deployment models for MinIO on VMware vSAN data persistence platform. The first deployment model is the vSAN SNA. The use case here is you have a consolidation need. You want to consolidate block and file as well as object store modern and traditional workloads on the same cluster. So vSAN SNA gives you a way to turn off the replication on vSAN, get the MinIO efficiencies, and still use that same cluster for all your workloads, right? So that is the consolidation use case. And now this is also easy to start using because you don't have additional deployments or investments. The vSAN direct use case is you have a performance cost optimization need. You're looking at bare metal, but you want a turbocharged vSAN management, Kubernetes consumption models. So that's your best bet for those kinds of use cases. So vSAN direct fits the bill very nicely in that case.
Got it. Got it. So this one, I think probably Urs is for you. Can you review a use case for S3 MinIO, a 4-node cluster in front of Cumulo to allow it to be an S3 target?
So MinIO out of the box has a mode. The code supports a gateway mode, and you can put that on top of NFS or CIFS, any kind of filer setup. But when you're talking about, in all of these discussions, we are talking about MinIO is being used in server mode where it does the full-fledged object storage stack, the erasure coding, replication, all the pieces. There is a way to do gateway mode use for transitionary purposes when you're migrating data and things like that. However, there are two separate use cases.
Got it. Got it. So this one is for Gopala. So what are the required components from VMware to enable these S3 object stores, particularly in MinIO?
Right. So the primary packaging option that we have for MinIO is VMware Cloud Foundation with Tanzu, right, which includes vSphere Enterprise, vSphere with Tanzu, NSXT, vSAN Enterprise, all of these components that are required for getting MinIO on the data persistence platform. So those are all the components that VCF includes. So VCF is the primary packaging option. But that said, you can also get this by choosing the individual components, vSphere, vSphere with Tanzu, NSX, and vSAN, even outside of VCF. So those are the two options for customers.
Got it. Okay. Question around availability.
This will be available soon, very soon. So we would love to have you try it out. So yeah, looking forward to it.
Okay.
All right, I think we are at the top of the hour. Should we? Yeah. So thank you everyone for joining. Looking forward to having you use our integration. Thank you so much. So Drew, want to take it over?
Well, thank you, Ugur and Gopala, for taking the time to speak with us today. As a reminder to our audience, you will receive a follow-up email with the on-demand link from today's webcast. To find out more about the VMUG webcast program, visit vmug.com and check out the education page. Please make sure to complete the short online evaluation that will pop up as you exit that webcast and let us know how today's session went. And from all of us here at VMUG, thank you and have a great rest of your day.